I'm going to fly through this, but you guys can speed it up, slow it down, whatever you need to do, pause it, replay it. Just make sure you take notes so you understand what we're doing. All right, so you got some problems. I need you to understand what a ratio is. Okay, a ratio. All right, and a ratio is just simply, let me just change this color right quick. All right, a ratio just simply is a comparison of two things, a comparison of two quantities, comparison of two quantities. They can be written as a fraction. You could see comparing A to B like this, and with a semicolon. Someone could say A to B. All right, that's another way you could see it. Or you'll most often see it as a fraction, A over B. So those are all ratios. Okay. So now you want to be able to use these ratios though. So for example, if I said that, all right, so your ratio of faculty to students is 1 to 15. There are 675 students. How much faculty are there is the question. And so I'm just going to make sure I pay attention to the order. So that means the 1, it says faculty to students. So this is the 1, and this is the 15. Okay. So one way you can solve a problem like this is with something called a proportion. A proportion. All right. And those are when you're talking about two equivalent ratios. So in this case, if I want to solve this thing, I'm going to have to say, okay, well, there's normally one faculty member for every 15 students. So since these two items are going to be proportional, I want to know, so I use my equal sign, how much faculty, so that's X, that's the thing I don't know, if there are 675 students. All right. And proportions are probably one of the most useful things you can use to solve, anything. If you don't remember how to solve proportions, you just cross multiply and divide. So I'll cross multiply here and I'll cross multiply here. So what I'm going to be working with is 1 times 675 on the left and 15 times X on the right. And then I'll divide by 15 on both sides because that's how you math. All right, and then 675 divided by 15 is 45, and so that's going to be 45 equals the X. So that's what will go right here, 45. So if you have 675 students, then you got to have 445 members of the faculty. All right, so that right there is example 1. Okay, so I use proportions. All right, next. All right, so TK ate 53.5 hot dogs in 12 minutes. Find the unit rate. So we're going to talk about rates when we're talking about rates, ratios, and proportions. And the rate is just a ratio of two quantities. Some really popular rates that you can think of are something like miles per hour. Right? That's a rate because you're saying to yourself miles per hour. Notice that is a ratio of two quantities. All right. A unit rate is with a second quantity unit of 1. Okay. So if I went 120 miles in 2 hours, sure, that's a rate. But most people talk about things in terms of a unit rate. And so instead of saying I went 120 miles in 2 hours, you would say you went at a rate of 60 miles in 1 hour, 60 miles per hour. Okay. So we're going to do the same thing here. We're going to talk about this, and this will be example number 2. TK ate 53.5 hot dogs in 12 minutes, and we want to know what the unit rate is. Remember, a unit rate is a rate with a second quantity of 1 unit. Okay, so when I go to solve this, I'm going to draw out my comparisons like a proportion. I prefer proportions almost all the time. So we'll say 53.5. Those are the hot dogs. All right. In 12 minutes. And we're going to set that equal to, we want to know the unit rate. So that means when one of these quantities is one, when the second quantity is 1. So the second quantity is like another way of saying the denominator, the number on the bottom. So that's going to be 1 minute. All right. So I want to know how many hot dogs he was able to eat in just 1 minute. And how do we solve that? Well, the way we solved the last one, we're going to cross multiply and then divide. We'll cross multiply and divide again. So that'll give us, see, 53.5 times 1 is just 53.5. And then 12 times x is just 12x. And you'll divide by 12 on each side. And then after you divide by 12 on each side, you'll get that, oops, 53.5 divided by 12, you'll get 4.46. He was able to eat approximately 4.46 hot dogs. Okay, so that'll be the x. All right. So that's how unit rates work. We're always saying something with 1 as the second unit, then unit in the denominator. So now, so I got this 25 degrees Celsius per kilometer. They want me to convert it to degrees per meter. So you've got this thing called a conversion factor that you're going to want to learn to use, a conversion factor. All right. And that should be, that should set off some alarms in your head. That conversion factor is something that you multiply by, right? Something that you multiply by. Right. So if we want to convert 25 degrees Celsius per kilometer to something, they want us to convert it to degrees per meter. Okay. And so what I'm going to do is I'm going to take what they gave me. I'm going to take this 25 degrees Celsius per 1 kilometer. All right. Then I'm going to multiply it by this conversion factor. And the conversion factor always needs to be, yeah, I don't remember what I was saying 2 seconds ago, but here's the rest of this problem. So the conversion factor is the thing you're going to multiply by. So to figure out your conversion factor, what you need to do is you're going to take, let's see. So for example, for this one, we're trying to change the kilometers to meters. All right. And so we're going to just change the place. So, so the conversion factor is I'm going to change the kilometers and put it on, since it's on bottom originally, now I'm going to put it on top in the factor. And then down beneath, I'm going to take meters and write down how many meters make up 1 kilometer. And this is just something you have to know from, like, 4th, 5th, 6th, and 7th grade. So we know that there's 1,000 meters in a kilometer. So once I go and multiply that out, these kilometers actually cancel out because it'll be kilometers on top of kilometers. So you're going to end up with 25 degrees Celsius per 1,000 meters. And you go ahead and divide that up, and you'll get your final answer. Once you divide that up, you're going to end up with 0.025 degrees Celsius per meter. Right? And that's how you handle those conversions. I do have to give you a second example of a conversion though, because sometimes they ask you to do something even bigger. So for example, this is going to be example B of this. And so this time they're going to say, give me a second. There you go. So the question is, or the statement is, convert 52.68 feet per hour into inches per minute. So now we've got 2 things changing. The feet is changing to inches now, and the hours are changing to minutes now. And so we're going to have to switch this up as well. So we're going to actually have 2 conversion factors. There's 2 conversions happening. Before, the degrees stayed the same, but the kilometers changed to meters. But now the feet, there's 2 things changing. The feet are changing to inches, and the hours are changing to minutes. So when we do this, we're actually going to have to convert twice. So we're going to have 1 conversion here. We're going to actually have 2 conversion factors, I should say, and another conversion factor here. So let's look at what these should probably be. So let's say I want to change the feet first. Okay, so this will be my conversion for feet. So if feet is on the top before, this time feet's going to have to be on the bottom, right? So we said that. And so, and on the bottom, we want that to be the 1 foot because we're trying to see. Let me do this right here. And there's 12, and we're trying to change it into inches. So there's 12 inches per 1 foot. Okay, so that'll be right there on the bottom like that, and 12 inches will be on the top like that. The other conversion we're making is into minutes. Okay, this is going to be minutes, and so minutes to, so from hours into minutes. And so this, in this case, we're going to say, all right, the hours were on bottom, so I'm going to need the hours to be on top this time, for sure. So 1 hour is how many, 1 hour is how many minutes? That's 60 minutes. 1 hour is 60 minutes, right? And so now we'll just multiply all of this. So if I do the first one, I multiply all that out, I'm really just going to end up with 6. Let's do a different color. I'm really just going to end up with 632.16 inches, because remember the feet cancel out. There's feet on top and feet on bottom, so they cancel out. Inches per hour, per 1 hour, right? Okay, but then we're also going to, remember, we're going to multiply that again. So that was our first conversion, converting the feet to inches, and now we're going to do another conversion, converting the hours to minutes. All right, so we're going to multiply by, the 1 hour and the 60 minutes, which ends up really just being 632.16 divided by 60, and that's going to give us 10.536 inches in 1 minute. All right, so that'll be our final answer. 10.536 inches per minute. And that's that one there. All right, here's the last one. We're going to use rates, ratios, proportions to figure out a map, to figure out an actual distance from a map distance. So here's our map over here. All right. And look at my boat and fishes, and it's really amazing. And so you should be able to tell that this is Lake Michigan simply by my expert drawing. Now, so we can see that on the map, and if I were to take a ruler out and measure this, I could say, okay, Evanston is apparently 0.625 inches from Chicago. All right, 0.625 inches from Chicago. But that's on a map, not actually 0.625 inches away. Okay, so I need to figure out how far away they actually are. Well, if you notice, they actually gave us this little scale on the map, and they say every inch is 18 miles. Okay, so if I were to write this out and say, all right, so the map, and I'm always going to compare the map to the actual. Compare the map to the actual, right? So in this case, I'm going to say, all right, well, on the map, it's 0.625 inches. All right. How far is it actually? Well, I actually don't know. But I do know that, according to the map, it says for every 1 inch you see, you can consider that 18 actual miles. And from here, you should be able to tell and take a guess of what you're going to do. Yeah, you're going to cross multiply it, right? And so your answer is going to be whatever 0.625 times 18 is, and that's going to equal just 1x, right? So it'll be just that. That'll be fine. All right, and so I'll go ahead and plug that into a calculator and see what we get. And we end up getting 11.25 miles. Okay, so we can reasonably say that Chicago is only 11.25 miles from Evanston, which makes sense because it's not a full inch away. So we should be good to go with just that there.